In this example, we will design a cross section that has the over reinforced section and suggestible moment carrying capacity for the particular section. So the example is the 230 mm width and 400 mm depth has been given, and we have a 300 mm square area of steel is provided, and the concrete is 20 MPa and steel is 250 MPa. So let's go for solution. So effective cover equal to 40 mm. Assume. So that means if you have a steel somewhere here, so the effective steel cover from center of the steel to the edge is 40 mm. Okay. So now effective depth equal to total 400 minus clear, I mean the effective cover is 40, which is equal to 360 mm is the effective depth. We can name it as a D. Okay. So now, as usual, for FE 250 MPa, the XU by D limited value equal to 0.53. So as per the standards, the actual XU by D equal to 0.87 Fy AST divided by 0.36 FCK BD equal to 0.87 into 250 Fy, and AST is 3000 by 0.36, FCK is 25 and B is 230 and effective depth is 360 here, 360. So this comes around 0.875. Now, so XU limited is 0.53 and XUD actually is 0.87. So that means XUD is greater than XU by D limited value, right? Hence, it is over reinforced section. So over reinforced section. So when the section is over reinforced section, normally we will design for the balance section and we don't allow to design the over reinforced section. So in this example, they have already provided 3000 mm square of the steel. So that means the cross section already has the designed for over reinforced section. However, the moment carrying capacity we need to be restricted with the balance section. Why? Because generally for the reinforced concrete, the failure strain in the concrete reaches earlier than the yield strain of the steel. In simple words, the concrete fails first before the steel fails. That means steel, we are providing over steel, right? Just put in a simple words. That's why the concrete fails. And the cracking will not occur even before the concrete crash and collapse. So that means before prior to failure, the cross section will not give any warning and it fails the concrete all of a sudden. So that's why we normally won't design for the over reinforced section. Even if there is the steel has been provided more than which is required to the balance section, we restrict the load carrying capacity limited to the balance section. Now, one should know what is the balanced moment carrying capacity. We have used before two, three standard equations. Even you can use this equation to calculate the MU limited. MU limit equal to 0.149 FCK B T square. This is for Fe 250 grade steel straight away equation 0.149 FCK BD square. Just keep in mind, it's very easy to calculate the balanced moment carrying capacity of the section. So now 0.149 FCK is 25 and B is 230 and D is 360 whole square, which is equal to 0.03 times 10 to the power of 6 Newton per mm. So convert into kilonewton meter. 1 kilonewton meter equal to 10 to the power of 6 Newton per mm. So that means 111.03 times 10 to the power of 6 by 10 to the power of 6. Then you can make it as a 1 kilonewton meter. So this and this will cancel, which is equal to 111.03 kilonewton meter. So this is the balanced movement carrying capacity of the section. So that's why we should allow the beam should take care of only balanced movement carrying capacity, so that the section, even though the reinforcement is provided over, we restrict it to the ultimate moment carrying capacity of the section equal to balanced moment carrying capacity of the section. So this is the balanced moment carrying capacity. However, if you provide the actual steel and then find out the moment carrying capacity based on the equation, standard equation, Mu equal to 0.87 Fy AST D 1 minus AST Fy by BD FCK, which is equal to, substitute all the values. So 0.87 250 into 3000 into 360 is the depth of the section. 1 minus AST is 3000 into Fy is 250 by B equal to 230 and D equal to 360. FCK is 25. So if you calculate this value, this comes around 149.79 into 10 to the power of 6 Newton per mm. Convert this into kilonewton meter, which comes around 149.79 kilonewton and meter. So this is the actual load carrying capacity of the section based on the steel provided of 3000. But however, the limited moment carrying capacity, balanced section load carrying capacity is only 111 kilonewton meter. So ultimately we need to take the minimum one. So minimum one means 111. So if you consider this and this, the ultimate equal to the minimum one 111.03 kilonewton meter, either load or moment. So the ultimate moment carrying capacity of the section is 111.03 kilonewton meter, 111.03 kilonewton meter. Thank you.